Hello, Professor. We're here to demo our project for you. I'm Daniel Katie.
Nate.
Christy.
I'm Gavin. I don't know if I got in camera there, but here I am again.
All right.
So here's our final enclosure. I'll take the lid off real quick just to show you what's going on inside. I'll show you in picture form what's actually the actual constituent parts here. I don't want to take it apart right now. So we have the HDMI in, which is coming from our video game console behind the monitor here. We have the HDMI out, which is going to this computer monitor. And then we have a power cable, just a wall adapter plugged into the wall. And then we have the cable that leads to the glasses, which Christy's holding there. Running down the checklist of the grading criteria that we came up with, we have wired the LEDs into the glasses. I'm not sure how well this is going to pick up for you. So from the front here, we have the front right LED, the rear right. We actually have two for the center channel here because we couldn't just put it right in the middle. It wouldn't pick up for the user. So we have two, and they kind of just mimic each other. We have the rear left LED and the front left LED here. We have inside of our presentation, which we'll attach, we have the wiring diagram for what actually, for how we actually made that. So we've wired the LEDs. Second item on the list, we've assembled everything into the enclosure, and again, we'll go into that in more detail. The final circuit board you've seen. It'll probably that'll be best explained in a picture as well. Finish the Arduino code. Well, we have about 1,000 lines worth of Arduino code here. I assure you that is done. If you care to see that, you can. We can send that to you, but I don't know if that's something that. Basically, I guess the proof is in the pudding, right? We'll actually show you it in action. Now, Bluetooth functionality. There's our Bluetooth module here. It's actually already paired to this tablet and connected. So you see if I hit this LED test mode button right here, it's running through each LED and ensuring that each one is wired correctly and that all of the colors are actually showing up for each one. And then we have a bunch of other functionality within this app, which we will demonstrate in due time here.
Can we get all the grading criteria?
So next item on the grading criteria is the phone app. That we'll go over. Demo final product by video. We are doing that. And add optional blink mode. That's a function that is in here, and we will show that as well. So here we go. So I'm going to be playing, and we figured this is probably the best way to show this. So I'm going to play, and it's going to show what's happening on Christy's cute face there. So throw a grenade. If I throw a grenade right in front of me, you see that the top LEDs are lighting up. So we have, here's the front right LED, the front left, and then the two center channels, which are always going up together. So a grenade to the front is going to cause all of those to light up. If I throw one to my right, it's going to cause the right two to light up. I don't know why we also got a little bit of action in the front and the rear left there. That's strange. And then if I throw to my left, that's going to cause the left two to light up. And you'll notice since these are grenades, those are low frequency sounds, so you're primarily getting a blue or a light blue color in there. If I were to switch, this is a pistol. This is sort of more middle frequency audio. So you're getting some red and some green color in there. If you remember our color scale, lower frequencies are blue, then it goes up to light blue, green, yellow, orange, and red. So yeah, green is middle frequency, red is higher frequency. And now we'll go over the different functions of the app. So here are all the default values. So the first one here is LED brightness. It's defaults to 100. That's what you just saw. I'll turn it down to 22 here. And you can see that the LEDs are a lot dimmer. And Christy is having a not as hard of a time dealing with that brightness. The next one here is volume threshold. So that indicates basically the minimum amount of volume that will cause an LED to light up. So it defaults to 25. So you see if I throw a grenade about 75 feet away here, let me turn up the brightness so we can even see this better. So I throw a grenade here. Note the level of brightness of that. Now if I were to crank up the volume threshold to 63, well, this might not even light up at all because the sounds were under the volume threshold. I'll bring that back down to the default. We have a couple samples here, a couple functions here, samples per window and samples to pass. These basically, these constitute this thing we call a windowing function, which basically it reads multiple samples at a time, and it will light up the LEDs after it's processed all these samples and determined what is the highest frequency audio component from all of those samples. It's kind of a mouthful. It's a little hard to explain, but there it is. We've got how many LEDs to light at once here. It defaults to all 5. If I wanted to make it so that only one LED will light up at a single time, I could do that. I wouldn't recommend it though. It kind of causes the LEDs to sort of fight between one another. But it is an option in there. You can set it between 1 and 5. Now I've got a single color mode here. I'm going to go ahead and activate that. So now, basically, all the LEDs are going to light up blue because I have it set to single color mode blue. So you'll still get the brightness information, but you won't get the different colors. So, a grenade thrown further away is going to cause the LEDs to light up less than something thrown close, but you're losing that frequency information. So if you find that stuff distracting, then you can use this single color mode. And if you want to change the color of single color mode, well, there's yellow, for instance. Now here's blinking mode, which is something that you and also our senior design instructor had recommended. So basically the LEDs are going to blink at a rate proportional to the frequency. So a low frequency sound is going to cause a lower frequency blink. Higher frequency sounds, higher frequency blink. So here's something of a low frequency blink. It still looks somewhat high frequency. That's just because the audio, we have to portray that information to the user quickly. If I wanted something of a higher frequency blink, there's sort of a mid to high range frequency blink. Yeah, we haven't, these things aren't perfect, but we've worked pretty hard to get them to where they are. Yeah, we think that in the future, with a lot of with some higher level sort of DSP, we could really improve it, but it just wasn't really in the cards for our project. And that's pretty much it. There are a few more options here, but I'm gonna leave those alone here. Let's see if we have missed anything here. That is about. Oh yes, so we have some pictures we can go over as well. Actually, here's just our test rig. Are you seeing that well enough?
You want to make it a slideshow?
Oh sure. So there's just our test rig, which I don't want to actually have it. Okay. So here's our prototype glasses, which I can also show you. Actually, I'll just show you these in the flesh. So yeah, we made these out of a pair of chemistry goggles, and it's just got a ton of wires in there. And you see the LEDs in the corners here. And then all of the wires are fed through this ribbon cable here. And basically what we noticed with these was that there's just entirely too many wires. We wouldn't be able to fit all of these wires into a pair of glasses like this. So if you remember when we talked before, we mentioned we'd found these individually addressable LEDs. So that's what enabled us to actually fit all that into there. Instead of 20 wires running through this, it's only like 4 wires running through the glasses. And then there's our finished glasses, close-up views. So this is kind of how we constructed the box. Actually, you want to go over this, DK?
Sure. So here you go. So basically, this is just some foam that we cut out this little portion in the center in the shape of the HDMI box, and then just laid this foam down inside of the plastic enclosure that we purchased.
Here you can click the mouse. Use the right click actually to go forward.
Okay. Yeah. So there you see the HDMI box fitting right nicely there in the little foam cutout. So then here's the enclosure. These are the holes we cut out for the power, the potentiometer, and the signal coming from the glass or to the glasses. Excuse me. And then there's the HDMI in converter. So this is going to the HDMI box, and then this is coming. This HDMI in. Yeah. This is coming from the Xbox, and then going into the HDMI box. And then this is coming out of the HDMI box, and then this is your HDMI out cord going to your monitor, basically. And yeah, we pretty much just glued those into the holes we drilled out for those individual components. There's pretty much the HDMI box sitting in there, pretty much the same thing. So this is a little rack we found. What was it? What did it come off again?
I think it was for a PC hard drive enclosure.
Okay, yeah. So it just so happened that this rack felt really, really well into this enclosure. It covered up the HDMI box perfectly, and it was the perfect size so that it just fit really snugly in there. And if you want to show.
Yeah, so as you can see here, we really lucked out in that this metal rack fits perfectly into here. You don't even need to screw it in or anything. It just snaps in there perfectly. And you can see sort of under there, those lights are actually the HDMI box under here. So this thing actually presses down firmly onto the HDMI box. And the result is that you have this thing that, nothing is shifting around in there, but it's practically a screwless design, which is really nice for us.
So pretty much then we just mounted the circuit board on top of the rack, and then we just made sure that so that it didn't short out on the circuit board, to put some rubber on there so that it insulated it really nicely.
Right, yeah, I don't know if you can see here. Yeah, just right there, just these kind of rubber standoffs that keep the circuit board mounted above this metal rack.
And yeah, so then we added these RCA ports and then the power port.
Oh, you know what? Let's let do we want to let Nate go over some of the stuff?
Yeah.
Do you want to do the live, the real one, or this?
I mean, if you want to.
We should probably go into here. You want to go over this stuff?
Sure. Yeah. All right. So this is an overview of our circuit board here. This is our final design.
I don't know if you can see this text, but
yeah, it looks a little bit blurry, but I'll point to it. So here's our Bluetooth module. This sends and receives from the tablet or phone app. We have our power coming in here, or excuse me, going out to the box here, and a decoupling capacitor just to smooth out the power. And up here in a row, you can see all of the MSG EQ7s, which take the signal from the HDMI box and give it to the Arduino so that we can send it to the glasses. Here is the power for the board itself. Here is the standard size headphone jack that we use to send out to the glasses. The 8-gain potentiometer we use as the knob to adjust the volume levels. And here is the brains of it all, the Atmega 328, which is commonly found in the Arduino Uno, as well as its canned crystal right here.
Sorry, I'm trying to closer here.
Just provides a clock signal for the Arduino itself. And here is the input for the audio signals from the HDMI box. So basically, the audio travels through here, goes into these chips, which then send a signal to the Arduino that sends it back out to the glasses themselves.
Right. And so I think that I'm correct in saying that the audio that comes out of these, that's the audio that can be adjusted by the potentiometer. So it's being adjusted before it gets into these chips. And we found we thought that was an important step because these chips have sort of a limited dynamic range. There's the underside of the circuit board. We put a lot of effort into that. We had to use very thin 30 gauge wire in order to make that happen. Let's see, are we missing anything here? I guess I could go over the Arduino code really quickly. This is just a bunch of text here. So basically, the gist of the code, like I said, it's about 1,000 lines, but it reads the amplitude values from the MSG EQ7 chips. It tries to find the highest amplitude value for each chip, and then also the corresponding the corresponding frequency component for that chip. If it's over a certain threshold, it will send out the LED control signal. And then also along the way, we're reading the Bluetooth serial buffer to see if anything has come in from that. If there's anything that needs to be changed within the app, any of the variables, then we'll make the changes at that point. And then we call a bunch of filtering functions, essentially, which are what kind of do the work in terms of should we light these LEDs and how should we do it. I think that's going to just about do it. Let me give this video's getting a little long. I know you got things to do. Yeah, unless, shoot us an email, I guess, and let us know if we've hit on all these criteria. I think we have, though. So thank you very much for your help, from me and all the gang. Yeah, and we hope that you're able to drop by and see us at the final demo. Thank you.
Bye.
Bye.